In this series of videos, we'll be going through the basics of neural networks. And in this video, we'll talk about a neural network in its most basic form, which is linear regression.
So first, let's start with an example. Let's say we wanted to make an app which predicted house pricing. Well, obviously there would be multiple factors which would affect the price of the house. So we can make a table of that. So first we would have square footage. We have total area of the lot. And maybe the amount of bedrooms, bathrooms, maybe the stores, and maybe we could also give a rating for how nice the house is. And we would take all these and somehow will give us an approximation of the price. Yeah. So how would we do that?
One way to do this would be to research housing prices and maybe come up with a formula for how these different factors could affect the house price. Now that would be pretty difficult to do. So instead, maybe we could have the computer do some of the work. How would we do that? Let's say I want to make a very basic formula to computing housing prices. Now, square footage of a house, each square foot adds a certain amount of value to the house. So let's say each additional square foot, without changing any other factor, would add $100. And then each acre that a house has would also affect the price, maybe let's say by $15,000 times. Plus maybe the amount of bedrooms, each bedroom independently might add, let's say, $5,000 to the house. And we could do something similar for the rest of the prices. And maybe if we do something like this, maybe we could approximate the price of the house. What we could do now is, instead of us having to guess these values, we could have the computer guess them. Well, first, let's make some definitions. These values are actually called weights. Well, to have a program find these values, we actually need to know what these values should be and what they should look like. And the way we do that is with the loss. So the loss is just a measure of how bad this algorithm works with these weights. So that's the loss. Well, so that means that our goal to find these values would be to minimize this. And the way we do that, well, we can actually just use calculus for that, right? If we could define the loss, of the function, we could take the derivative of it and find minimum, which would work if we could do that. So let's try to make all these variables in terms of vectors. So the way we'll do that is we'll say the weight, make a weight vector. And the weight vector will be a collection of weights. And so it will be a column vector. I'm not sure why, but so it looks something like this. Okay, so that's the weight vector. also make a vector. Well, I need to make more like a matrix, but for now I'll just make a vector for each one of the houses. So let us call this H. Okay, and H will just be all the data for one house. So this will be like square footage, land area, but we'll just do this. We'll just make this later. First, this is just HN. So I don't know, right now we have 5 variables. 1, 2, 3, 4, 5, 6. So let's do H6. Okay. Oh yeah. H6. And then we'll also make one more vector. Not really vector, I guess, but we'll make one more variable, which is the price for any house. For house N, or whatever, just equals price. So that's just so that's almost the price. That's the actual price. Now, what we could do is you could take advantage of matrix vector multiplication, and we could do this, but using vectors, by using vector notation. And the way we can do that is by multiplying each individual house, really any individual house, by the weight vector. And this would basically just look like any normal vector multiplication, right? Alright, what would that look like? That would be W1, that would be HN, that would be the first variable of the house times the first weight plus second thing in the house times the second weight, etc. Right? So it's really the same thing as this. It's just a little bit neater. So this would be approximately equal to the price of N, where it's supposed to be. Okay, so that's that. Now, how could we find N then? The weight vector now? Well, we could also write the loss in terms of vector multiplication. Now we'll do it like this. The loss equals 1/2. We're doing 1/2. We'll see why we're doing 1/2, but for now. 1/2. And we'll do N equals 0, 1, 2, 0, 2, the amount of houses. So we'll just call that A. Okay. And for each house, we'll multiply by the weight vector. Right, so that's our approximation of the price, and we'll compute the error by multiplying it by the actual price. Just like anything else. Now, we do need to take an absolute value of this, but since we're going to be taking a derivative on this, we'll square it, and also we put the half here so that it evens it out. So now we can take a derivative on this, and pretty simple. All right, we'll just do the derivative of that. What does that equal? Well, it's just this.
right, it's just a channel. And why do we take a derivative of this? Well, the way you can minimize this function, the loss function, and by minimizing it, you would be getting the weights accurate, as you say. So the way to minimize it would be to just look at the derivative, right? And if the derivative equals 0, then we get what we wanted. You can't, it would be pretty hard to make this 0. So instead what we'll do is we'll do what's called gradient descent. Let's say we were to have a curve, say like this, right? And we want to find the bottom of the curve. So how could we do that? Well, one way to do it would be to guess a random point on the curve. So let's say we guess like right here. So that's our guess. So now we could take a derivative of that, which will give us the slope of this line. Then we could say, well, it's approximately the next, if we go, we know that this is going to be a little bit closer, right, to this point, or really here. And then we could say, well, okay, well, we could get even more close. We could get even closer by making another one, which would be closer to that. And we could repeat a similar process until eventually we get to the actual one. We get to the actual point that we want, which is the minimum. So we could do the same thing with this derivative. But we have our weight vector, and we could subtract the derivative from that. Minus, now, the derivative. Now, it doesn't necessarily need to be like, if you do it to like here, it wouldn't work very good, right? Because let's say even we did it like here, and it would go past it, and then it would just keep on going back and forth, back and forth. So you really have to take small steps at a time. And the way we do that is we use what's called a learning rate. That alpha there. It's the learning rate to slow down the steps that it takes, so that it doesn't jump back and forth and not actually, and just totally miss it. So that's the formula for gradient descent. And if we repeat this over and over and over again, eventually we'll converge and we'll get to the best possible weight vector, which would approximate the price. In the next video, we'll try to write some Python code which will implement this, and maybe we'll also improve our algorithm a little bit.